So the first combination of capacitors that we're going to talk about is when capacitors are parallel. So if I put capacitors in parallel, similar to when we were talking about resistors in parallel, what does that do to the overall capacitance? Well, it's pretty simple. It's a little bit different than parallel resistors. In this case, if you look in your data booklet, if I put capacitors in parallel, their capacitance adds together. Okay, it's a way of like accumulating like batteries together, for example. So what I can say is that the total capacitance of capacitors in parallel is equal to the sum of each individual capacitance, C1 plus C2 and so on, depending on how many I have in parallel. Likewise, the total charge that would be on these capacitors is equal to the charge on one plus the charge on the other. All right, so those are two important identities to understand. So here I have an example circuit where I have 10 volts attached in parallel to two capacitors. This capacitor, two straight lines, is 1 farad. The other is 2 farads. And each of these capacitors experiences 10 volts of potential difference across it, like normally we would have in a parallel circuit. So in order to calculate the charge, for example, on each of the capacitors, I would need to go and look at what the total capacitance is in that parallel branch. So C total, the total capacitance in these parallel circuits, is equal to the sum of each one. So 1 farad plus 2 farad is equal to 3 farads, okay? And Q total is going to be the charge across one plus the charge across the other. To find the charge, I use the formula C is equal to Q over V. So to find the charge, V times Q, V times C, the capacitance, will be equal to Q. So 1 farad times 10 volts will give me 10 coulombs. 2 farads times 10 volts gives me 20 coulombs. And the total charge across both of those is going to be 30 coulombs of charge. Likewise, I can, instead of looking at them individually, I can just sum them up and I can look at the total. So the Q total of charge across those components is going to be the total capacitance, which is 1 plus 2, 3, times 10 volts is 30 coulombs. Okay, and that's how we deal with parallel capacitors. You just add them up, and that gives you the total capacitance times the voltage going across would give you the total charge. And we can determine how much of that charge is on each component by saying 10 volts and 1 farad or 10 volts and 2 farads.